All right, hello everyone, and welcome to today's webinar. My name is Phoebe Byerly, and the Center for Green Schools at the U.S. Green Building Council. We are pleased to host this presentation today about zero energy schools, the design, construction, as well as operations of those buildings in partnership with New Buildings Institute and VMDO Architects. I want to thank Wyck and VMDO Architects for sponsoring today and being a partner with USGBC for a long time. So thank you. For those who are joining, feel free to introduce yourself in the chat window and let us know who's on the call. We have a lot of folks joining from all over the world today. And as I said, we're excited to lead this conversation. So maybe in the middle of a global health pandemic, but this panel and those on the call also know that we're facing a climate crisis of significant concern. Those in California are maybe facing that and feeling that with wildfires in a real way. We have friends in Iowa who were impacted by derecho last week. So it's important that organizations like NBI and VMDO are leading and setting a vision for a different way how buildings are interacting with climate change and possibly being a positive impact on climate change in the future. And also how zero net energy buildings can be resilient both to the climate crisis, but also in many cases, and you'll hear today, also resilient in terms of the health crisis we're facing right now. We're excited to announce that there are over 200 verified and emerging net zero energy projects across the country that are just educational institutional projects. And the New Buildings Institute will talk a little bit more about their research and tracking of those later, as well as the increase in codes and policies that we're seeing across the country coming up that are promoting net zero energy and carbon as standards now and in the future. So the trends are clear, and we're excited that net zero energy projects are here to stay. We're going to talk about that today, how you get there, what resources are available to help you on your journey. So excited to see everyone, and as I said, across the country. Hi, Russell from New Zealand. That's awesome that folks are waking up early or staying up late to join us today. I just want to remind folks that we are recording this call, and slides as well as the recording will be shared later. So we'll send out a PDF of all the slides. I'm sure some of you will be tempted to review those later because they're full of great information. All right. So for those who are not familiar with the Center for Green Schools, we are part of the U.S. Green Building Council, and our focus is in the K-12 sector. Our vision is that all children will have access to a healthy, high-performance school, and we work in various areas to make sure that happens. One of them is through education, and these webinars are a way that we do that, partnering with organizations and leaders in the industry and bringing best practices and on-the-ground stories so that we can share, not have to repeat the wheel, and move progress quicker. So thanks again to everyone who's helping make today's event possible. I am joined by my colleague, Kristen Keim, who's based in DC on my team. And thank you, Kristen, for your help today. She'll be monitoring the Q&A and the chat box for questions and helping us at the end. For those who aren't already signed up for our newsletter or following us on social media, we welcome you to stay in touch and follow our great work there. So without further ado, I want to turn it over to our awesome presenters. We have two experts with us today from the Zero Energy Schools field. And as I said before, you're going to walk away with some great case study examples, resources on how to get started or continue on your path to zero energy projects, whether they're schools or something else. All of the resources today can apply. First, we have Reilly Loveland with us, who's project manager at New Buildings Institute. Reilly focuses on energy efficiency and zero energy in schools, and she's working on various really interesting projects, including the Prop 39 zero net energy school retrofit work based in California. So she has a lot of experience with zero energy projects and retrofit existing building efforts, as well as occupant engagement, which is quite unique. And she also works at New Buildings Institute to design workshops and a lot of the resources that she's going to share with you today. And we were honored to award Reilly the ambassador, the Green Center for Green Schools Ambassador Award this past March for advocating for sustainable schools. So she's a real leader in this field. Another leader we have with us today, Wyck Knox, principal at VMDO Architects. Wyck has 25 years of experience designing sustainable projects, and he's going to share some of his most recent work in collaboration with Arlington Public Schools, specifically with the Discovery Elementary School, which was a recipient of the COAT Top 10 Award in 2017, which is quite a prestigious award. Congratulations. It's also one of the largest IL-5 zero energy certified buildings of any kind, and was the first LEED Zero school certified by USGBC. And what's really exciting is that due to Wyck's work and VMDO's work, Arlington Public Schools is now pursuing net zero energy projects for their, I guess, maybe their entire portfolio going forward. And so he'll be able to talk about a project that just opened in 2019 and also one that's about to open next year. So, Reilly, I'm going to turn over the ball to you and have you share some of your work. And I think the next slide is actually the learning objectives for this call. We can just skip over those.
Great. Okay, I will. Oh, sorry, everyone. It's going to take me a minute to learn how to toggle the slides, but I think we're good.
Thank you.
So as Phoebe mentioned, these are the learning objectives for today. There'll be a recording so you can refer back to them. And I just wanted to say thank you so much, Phoebe, for this opportunity. As always, I just really value this relationship we have with you guys, and a social one and a professional one. And of course, hello to everyone in Iowa. I'm thinking about you a lot, so thanks for that shout out, Phoebe. So for those of you who are unfamiliar with New Buildings Institute, we're a national nonprofit, and we work to reduce energy and carbon emissions in new and existing buildings, as Phoebe said. We've been working in the schools market for honestly many years and are really thrilled for any opportunity to share the stage with people like VMDO and Center for Green Schools who are doing all of this great work. Oh, not that button. There we go. I told you it'll take me a minute. So today I'm going to be talking about how zero energy schools benefit not just the school occupants, but really entire communities. Zero energy and ultimately zero carbon in schools is possible and really doesn't have to come with this premium price tag that is generally, thought of with the zero energy school. And we know that the students and the teachers in these buildings benefit from the healthy and productive learning spaces. And to level set for anyone new to zero energy, a zero energy school is an energy efficient building that consumes only as much energy as it produces over the course of 1 year. So the first question I would get is, why should I go zero energy? And ultimately, how much does it cost? But we'll get to that. And in light of our current physical and political climate, students are really the ultimate drivers for change. And we've seen this enormous uptake in students demanding change in our systems and our built environment to mitigate climate impact. And it's really important that we listen to their demand and be the champions or the zero heroes that implement change that support their needs and the environment. Additionally, zero energy and zero carbon schools are really this evolution of sustainable high performance school buildings, which is something we're probably all relatively familiar with, because the concept of sustainable buildings has been around for quite some time. But these buildings, these zero energy buildings, are the current iteration and really the future of all buildings. They deliver cost avoidance from utility bills into the classroom. They create these comfortable and productive learning environments. They provide the hands-on, future-focused learning opportunities, and they can ultimately contribute in stronger and more resilient communities. So I'm going to talk a little bit about, or more about, why these buildings specifically contribute to the resilient schools and communities. So in light of our current climate and the spotlight on pandemic mitigation, zero energy schools are really a prime example of how we can utilize our buildings to increase indoor air quality and health. Many of our current buildings are nowhere near up to par with the indoor air quality standards that are necessary for occupant health, productivity, and wellness. So I'm going to frame this for you. In a paper that was published in 2019 by Lawrence Berkeley Labs, they visited 104 classrooms from 11 different schools. This is in California. And these schools had recently been retrofitted with new HVAC systems between the years of 2013 and 2016. And the team at the Lawrence Berkeley Lab monitored CO2 concentrations for about 4 weeks in each of these classrooms. And they found that 65% of the classrooms had elevated CO2. And elevated CO2, by the way, is defined as an average daily high of greater than 1,100 parts per million. They then actually went in and led this field team that inspected the HVAC equipment, and they identified issues like inadequate equipment or improper installation, controls were not properly set, so fans weren't operating at the right time, they had filter issues, there was a whole range of issues. And again, this is 65% of the buildings with recently renovated HVAC systems had elevated CO2 levels, and high CO2 can lead to cognitive issues, poor performance, inability to focus. I mean, there's a whole range of issues. And imagine issues like this in schools during the pandemic and then beyond. So in zero energy schools, special attention is paid to HVAC systems running as efficiently as possible. Otherwise, energy efficiency is at risk. And health does not need to suffer, neither does energy efficiency. So there we go. I'm going to take a step back so I can kind of define here what exactly we're talking about with HVAC systems and ventilation. And ventilation is, of course, the process of bringing outdoor air inside a building to dilute indoor contaminants, which is crucial to mitigating the impacts of things like the COVID virus or other pollutants, think freeway traffic stuff coming into the building, which is a big issue we have here in Portland, and I imagine a lot of other urban areas. So the solution we need is to ventilate more, right? Often with more ventilation, people think this is the opposite of zero energy or energy efficiency, but more ventilation does not have to mean more energy use. This is something that we like to call the health energy nexus or energy health nexus, where even though we're dependent on more systems, these systems are highly efficient and they're commissioned, so people are paying attention to them, so that those ones that were recently retrofitted might have more attention paid to them so they are operating correctly, so they can reduce energy while also increasing indoor air quality. Inadequate ventilation is a common problem among classrooms, also offices. I mean, this expands beyond classrooms, of course. And considering IAQ and energy efficiency has impacts on things like infectious disease transmission, indoor environmental quality, and then again, student health and performance. We'll keep coming back to that. So utilizing needed HVAC and other building upgrades as an opportunity to improve energy efficiency will improve the health and wellness of the building. And this is for COVID and beyond. And Wyck is definitely going to talk more about indoor air quality and health and how low energy versus health does not have to be a choice. But, improving air quality also depends on filtration. It's not just ventilation, because ventilation removes the indoor air pollutants and evenly moves it around to improve comfort and satisfaction. And adding in that element of filtration actually removes the particulate matter, like the COVID virus. So with increased ventilation, such as with a zero energy building, you have more healthy and productive spaces. So some of you may have already gone through this. How does this apply to my district? But you can get started now. If not, likely you already have. But you need to prioritize, because there's a lot going on and there's a lot you need to think about. Testing and commissioning existing ventilation, like those schools in California, installing MERV 13 or better filters. But of course, you can't just slide a new filter into any old HVAC. You need to make sure that your HVAC is MERV filter capable. And if it's not, consider portable air cleaners if they're not up to par. And then note which systems are not capable, because that's a future retrofit opportunity. And also continue to monitor indoor air quality. So monitor that CO2, you want to monitor temperature, humidity. There's been a lot of discussion that I'm hearing about how much of a role humidity and temperature plays in virus mitigation, which really takes me to my next slide, because I am not a COVID expert, but I've learned a lot recently, and we've really been talking about it a lot in the context of zero energy buildings. And I've really just barely skimmed the surface on the air quality issues facing schools, but these resources here can help you as you make your building decisions for mitigating COVID. It's important too to point out that we don't want to just think of zero energy buildings or HVAC upgrades only as a response to COVID, but this is an adaptation and a prevention technique for the future. So be smart, be thoughtful about the choices you make now, because these zero energy and high performance schools will be around a long time, and you're future-proofing schools to align with the climate action of those students I showed that they're demanding. And, you know, COVID mitigation and future-proofing are just some of the reasons why zero energy schools are important to pursue. And I mentioned these concepts in terms of air quality, but also earlier I alluded to these schools also providing things like better daylight, thermal comfort. They have these connected spaces, which contributes to the data you see here, the better test scores, health, comfort, staff, student ventilation. The list goes on. And these buildings can become living laboratories, and the school itself is a tool to enhance student learning. And Wyck is going to talk about that, which is great. You can utilize the actual physical building and the performance data for math and science that can align with next generation science and Common Core standards. This is actually a student performing a level 1 ASHRAE audit in Los Angeles Unified. I know other districts do that too. And so the reason we know all of this is because in 2010, NBI began tracking zero energy buildings. And at that time, few people believed that a building could produce as much energy as it consumed, but we knew it was possible because we were working with the people who had done it, like VMDO. So we started to track these buildings, and in 2012, we published our first list of zero energy buildings, and we keep updating this list about every other year, and we've seen this incredible exponential growth. Oops, wrong way. There we go. So in 2019, the NBI Getting to Zero list grew to over 600 buildings, and that's when we decided, okay, this is a really good time to produce a special list focused solely on schools and educational facilities, because we were seeing in the data that they're leading the entire zero energy market, comprising, this says 40%, almost 40%, but I actually think it's over 40% of all the buildings on the list now. And you can see here that there are two different colors on the graph. I'm pointing and I'm realizing you can't see what I'm pointing at. But the green represents zero energy verified buildings, which has verified that they consume only as much as they produce. And zero energy emerging buildings are in blue, and these buildings are well on their way to zero energy verified. They just might not have demonstrated that full year of operation, or they're still under construction, you know, anything like that. And these schools are in every climate zone, and the leading states are always fun. It's California, Kentucky, Massachusetts, Oregon, and Texas. And I'm sure Virginia is coming in soon. And because more and more of these schools are coming online, states and school districts are really starting to recognize the benefits, and they're starting to actually mandate zero energy and carbon construction. So these are just some quick examples across the U.S. The state of Virginia has actually mandated that all new construction be zero energy, all new school construction. San Francisco Unified and Salt Lake City School District have established resolutions that set forth this path to energy efficiency, zero energy schools, and renewable energy. And the state of California has actually mandated all buildings, including schools, achieve carbon neutrality by 2045, which means that these buildings will be powered only by carbon-free renewable energy. We're actually facilitating a cohort of 60 schools in California that are working to develop a roadmap for their facilities to get to zero energy because the state is mandating it. I should also kind of back up here too. And, you know, you've likely heard me over the course of this webinar use zero energy, maybe I said zero net energy, zero carbon, carbon neutrality, interchangeably. And there are many ways to classify zero energy buildings, but really you just need to know that these terms refer to buildings targeting energy efficiency first and then coupling that with renewables to get to that zero target. And zero carbon just means that they are a highly efficient building that produces on-site or procures carbon-free renewable energy. So that's the key part, carbon-free renewable energy. And that generally means that the building has no combustion on site. There are also different verification or certification approaches to zero energy or carbon. You know, International Living Futures Institute or ILFI certification has several options, as does LEED Zero. Phoebe's actually going to talk about LEED Zero in a second, but both are certification programs. NBI lists as a verification program. And they really all just differ based on how they treat on-site combustion or gas in buildings, how they're certified, how it might be calculated, and you as a project lead might decide that one is best for your district over the other. So Phoebe, I think you take over on this one, right?
Yeah, thanks, Reilly. I just wanted to take a minute to highlight for everyone what LEED Zero is all about if you haven't heard about it. There are 4 ways to get a LEED Zero certification. You can go to the next slide. We'll talk about carbon and energy briefly here. So just wanted to highlight that this was developed in 2018, and this certification is a complement to projects that are pursuing O&M certification, operations or maintenance, or a new building with LEED. And so Wyck's project in Discovery Elementary was pursuing LEED and net zero energy and was able to achieve a LEED Zero certification with really no extra work. So for those projects that are kind of on that path already, this is an awesome opportunity to kind of get a third-party verification and stamp of approval, essentially. For carbon, we're looking at net zero carbon emissions from energy consumed, as well as occupant transportation impacts. And this is looking at total carbon emitted minus the total carbon avoided to get a zero or a positive score to be able to certify here. And we're looking for 12 months of data, and certification lasts 3 years. For energy, it is source energy we're looking at, and a balance of zero source energy over 12 months. So what sort of energy is being delivered or used on site minus the total renewable energy that was developed on site or off site. I think that's what I'm going to stop there. Keep going, Reilly. The highlight of what LEED is all about.
That was a great segue to what I need to talk about. So thank you.
Good.
You have probably noticed that carbon is being thrown into the mix. Some of you have been around a while. I know that zero energy, you're probably familiar with zero energy, but now this is really about carbon, because now that we understand better what a zero carbon school entails, and we've talked about it on this webinar a little bit, and with climate change rapidly approaching, it's really become clear that we need to transition our building stock to be carbon emission free. You know, I've mentioned a few other states like California and New York have already mandated that this has to happen in their building stock, which includes schools. And calculating carbon can be kind of complicated, and the carbon of energy, or the carbon intensity of energy use, depends on things like local grid conditions, time of year and day. You can see on this graph that looked very foreign to me the first time I saw it, but I promise it's not that scary, that during the months of April and June, where the dark green is, there are generally more renewables on the grid, and because there's less heating and cooling needs, the grid is effectively cleaner. Whereas during the winter months for heating in summer, or winter for heating and summer for cooling, the grid is much dirtier in the mornings as we, flip on our heaters and our air conditioners. So understanding when our grid is clean and programming our buildings to be flexible to grid conditions is an important part of zero carbon buildings. And our grid is going to continue to become cleaner as more renewables come online and as more coal goes offline. And things like utility scale solar will also change the carbon intensity of the grid over time. You can see in this graph towards the bottom in the green again, that as time progresses through 2030, many states, jurisdictions, utilities, and school districts have set goals to be 100% renewable. So we're going to start seeing a lot more green come online. But, that's 2030 is around the corner, but it's not here yet. And as we wait for the grid to become cleaner and the cost of electricity is, continuing to fluctuate, energy efficiency is your least cost resource. So you don't have to pay for what you don't use. And more efficient buildings equals less demand on the grid during peak hours and more space for vehicle electrification and less money spent on procuring those off-site or on-site renewables. And evaluating carbon emissions in our buildings is incredibly important, but going to that all-electric and focusing on energy efficiency can really make this a whole lot simpler. And what helps that is fuel choice in your building has a large impact on carbon emissions. So electricity is the cleanest option, and in time will be 100% clean and carbon-free, as we've talked about. And natural gas really does provide most of the space heating in the U.S., but regional differences do exist where climate differences are significant. I could talk about that for a long time, so I will just keep going over that one. And in schools, specifically to achieve zero carbon, you really need to identify where gas is currently being used, the lifespan of the gas technology, and then how it's being maintained. So taking the gas out of your building, of course, may take time. I mean, look at the size of those things. And that's totally okay. And really, this is the perfect segue to a quick touch on a concept for how you guys can start to achieve zero energy and carbon in a way that is time and cost effective. And this concept is called getting to zero over time. And what this does is it really takes a long-term strategic approach to energy management, where the main focus is on the benefit to the learning environment. And this process leverages every opportunity to improve energy performance in the building life cycle. And that could be lighting retrofits, equipment replacements, modernizations, new construction, every opportunity. And you do this by the district setting measurable goals for your portfolio or individual districts and using policies and guidance documents to achieve the goals. And then, of course, come back and regularly report on your progress. And we've seen in our research that every project, every successful district has a champion. We like to refer to them as the zero hero. Oftentimes they're on staff, they might be a trusted consultant, committed board member, whoever, but it's really their job to establish those goals I mentioned and develop and implement those policies and align those with educational outcomes and make sure that energy is considered throughout the entire process. These projects set measurable goals or energy use intensity targets to guide both the design and operation. We generally recommend an energy use intensity of 25 kBTU per square foot or less. And if you're still learning what an EUI is, I'll refer you to some other NBI webinars that kind of give the basics of zero energy. So I'll follow up with that in the end. But 25 is really achievable for new construction. And you can still set this goal for retrofits. I'll talk about that in a second. And these can be integrated into those guidance documents like owner's project requirements, your RFPs, and then other district policies, contracts, or resolutions. Here's actually some great quick examples. I forgot to put this slide in. Most of you probably aren't doing a ton of new construction and likely have existing buildings. So you can set EUI targets for existing building renovations as well. You can set that EUI of 25. That's very doable in many places. But it might be slightly higher just because site or other constraints. And just here's some quick examples from Portland Public Schools here, where I am in Oregon, and then Boulder Valley. And I mentioned integrating these EUIs into guidance documents. So a key aspect of driving this process and ensuring the outcome is taking these goals and these targets you've set and incorporating them into something that holds people accountable and helps support the implementation. There we go.
Reilly, I'm just gonna, can you clarify if that was source or site EUI?
Oh, good question. Site. Oh, I love when people ask that. I should have included my site or source EUI slide. But thank you for asking. I saw someone earlier mention asking where zero energy schools, if they were only in affluent areas or in more disadvantaged communities. We have seen them all over. We've seen them in communities like Garden Grove School District in California, for example, is a very low-income school district. They have always prioritized student learning over their buildings, and they have some of the highest test scores in the state and some of the lowest incomes in the state. So we're seeing them everywhere, and those are retrofits too. So thank you for asking that earlier. I forgot to say something to that. I just mentioned these documents to guide this process. I'm going to just skip over this because I realize I'm low on time. But, you know, you've really started to set up your process and you have that documentation to guide it. And a core piece of this that I mentioned a little bit earlier is leveraging opportunities as they occur. This is so important. And thinking of energy in terms of every opportunity in the school building. Because if you think of the building life as a timeline, maybe every 50 years you need new HVAC, every 5 to 7 lighting upgrades, roof replacements, bond turnover. You can use these opportunities to make upgrades so that you're continually working towards that zero energy or zero carbon goal. There we go. New construction is generally easier for getting to zero. I say easier, obviously, with a grain of rice, grain of salt. The retrofit can be trickier, but ensuring energy as a core area in a building assessment or in your facility master plan can ensure that each project can move beyond like-for-like replacements. That's how you get the gas out of these buildings. Let's say you've got a gas boiler, time to go all electric, and you can really focus on getting the gas out. And then really internalizing that every decision matters on the path to zero. Every energy decision matters. All right, I'm almost done, I promise. So the key takeaways here is utilize the adaptability, the health, and the student outcomes as key messages for supporting your goal. NBI has a whole suite of messages that you can use with supporting data points to get to zero. Take them to any of your stakeholders, internal or external. This getting to zero over time approach is really successful in strategic long-term energy management. We have more webinars that really dive into that a little bit more, but I'm going to get to Wyck's more exciting case study. Appointing an energy champion is important, and utilizing every event in the building life cycle as that opportunity, avoiding like-for-like replacements, get the gas out, and then using guidance documents to guide the process and considering carbon and the impacts of natural gas. All right, I think that's it from me.
Thanks, Reilly. So much information, and we didn't even talk through the resources, which hopefully we'll have some time to get to at the end. And I'll pass the presentation off to Wyck, who's going to share some on-the-ground case studies of what his firm has seen in terms of success with net zero energy schools. Thank you, Wyck.
Thanks, Phoebe. So Reilly and NBI are an incredible resource. They have so much information, you know, that she went through that so fast because there's so much good stuff to talk about. And I would encourage everyone on the call that's involved with buildings to set a goal of getting your project in that report. That report comes out every 2 years as at least zero energy emerging. That's one of the goals in our practice is to always see our projects listed because we want to share this stuff. And so what we're doing here with the case study is I'm going to give you all the information that we have on these buildings. There's a lot of information on these slides. I'm only going to read one of them, which is the cost slide, because everyone wants to know about costs. And I'm also going to talk about a number of projects, not just Discovery Elementary. The slide on the screen right now shows 5 zero energy projects by VMDO. I should back up and say VMDO is a educational specialist. We've been designing schools for 44 years. We're based in Charlottesville, Virginia, and Washington, D.C. So Arlington is across the river from D.C. That's the Potomac River you see, and you can see the grid of D.C. on the right. And these are 5 projects, 3 of which are complete. 1 is under construction, and 1 is under design. And all 5 of them will be zero energy. All 5 of these are public projects on public project budgets, and not a single one of them got a grant or any additional funding to achieve zero energy. And they're in all kinds of diverse and different parts of Arlington, Virginia. Not that way. There we go. Okay, so Discovery, as Phoebe said, was certified zero energy in 2017. The building opened in 2015. When it was certified, it was the largest net zero building at the time of any building type, and the largest school as well. It has since been surpassed in that, which is a good thing, right? But we've got a couple of projects on its heels that we hope temporarily are going to also be the largest certified projects for a little bit. So this is the cost information. I always start with this and try to get it out of the way because people always want to know this information, and this is the only slide I'm going to read. So this project the budget was set in a capital improvement plan probably in 2012, 2011. It was only budgeted for LEED Silver and nothing else. It did not have zero energy goals. We brought that to the table and the client supported us. I always say that the secret of this project is the client didn't necessarily say yes, but they never said no. They said, you don't have any more money, but if you can do it with the budget that you have, we'll support you. So we did, and not only did we do it, we bid it several million under budget. And then when we finally closed out all the costs, when we finished construction, all the change order costs and everything, it was $32.7 million. So all in, that is $333 a square foot. We bought the PV. It's in the project. The school owns it. If you take that out and also take 2 big artificial turf fields that the county had asked for, we're about $300 a square foot. So and actually under average school construction costs in the area. When we finished, we still had $900,000 that we sent back to the school board when we were done. And along the way, we're saving between $100,000 and $118,000 a year in cost avoidance. When the students do come back, this will be year 6. So this is a building that's saved well over $500,000 so far. Another way of looking at that is your average cost for energy per square foot. So for this school district, you look at all their other elementary schools, the average cost is $1.32 per square foot for energy. At Discovery, it is 11 cents a square foot, which is a tremendous difference. And then this, of course, is the cost of the energy that we're using, and then we're offsetting all of that by generating energy. This is just the cost that we're bringing in on the meter before we offset it with all the power that we generate. So another way of looking at that is in this graph. So Discovery is the project down at the bottom in green. This is EUI performance compared to not just elementary schools in the school system, but all of them. So a huge difference from where they are in their other projects. I will say that the project up at the very top that is literally off the charts on energy use was their first LEED project. So LEED has come a long way from not necessarily having a focus on energy. You could get a lot of LEED points and be an energy hog. And it's now, the industry has changed, and so has LEED with it, which is a great thing. I'm going to also show you a project that's an addition and a renovation in a little bit, and that is the 5th project up from the bottom, the Westover Library, that was a LEED Gold project that opened 10 years ago, and it has an EUI of 53, which isn't bad, but not down at the level of below 20, 15, where we want to get on some of these really high-performing buildings. Still getting used to how advanced these slides go. So this is where we started with the school system. The school system had been doing some great things on energy conservation. When we started in 2013, we went back and looked at where they were 10 years earlier, and they had knocked about 10 EUI points off of where they were. But one of our first talks with them was, to really get there, we've got to take a massive cut in your energy use. We really have to cut it by 66%. And so we kind of randomly set that as a goal and came up with our target of 23. At the end of the day, we're performing much better than that. EUI changes year to year based on the weather, but we're performing between our best year's been a 14 and our worst year's been an 18 so far at Discovery. This is the dashboard that we created for it. So we track energy by the minute, by the day, by the week, by the month, and by the year. So the orange on the top is the energy that is being consumed. The yellow below the line is the energy, I'm sorry, the other way around. The top is the energy that's being produced by the solar panels. The yellow on the bottom is the energy that's being consumed. And then the bright line is the net result. So you can see, except for November, December, January, February, the building operates as net positive. And then over the course of that year, we are generating a lot more energy, almost 100,000 kilowatts more energy. You can see down on the bottom there. This is interesting looking at 17, 18, and 19. In 19, we actually just missed being net zero because of how much rain we had. And that difference is probably about two sunny days, 2 more days of sunshine versus clouds, and we would have been net zero for that year. So it's important to track your buildings and to track them every year and see how they're doing. So here's an aerial shot of Discovery. It has a 496 kilowatt array. At the time, our local utility provider would not allow us to have an array bigger than 500 kilowatts. Otherwise, they considered us a competing utility. They've since increased that limit, but once we realized that in design, it really kind of put a focus on, hey, we've got to hit that 23 or lower to make this work. So I want to talk a little bit. There's a reason that we call this Net Zero Schools Are Here to Stay, because when Phoebe and Reilly and I started talking about making plans for this several months ago, and COVID was happening, and everyone was panicked about the economy taking a dive, the kind of knee-jerk reaction from everybody was, well, we were thinking about that, but not anymore. You know, that's on the back burner. And if anything, I really want to counter that idea that these these things do not cost more, and there's basic practices that we can do to get there. And you'll have a building that is within your budget and also a healthier building. So I want to first talk a little bit about the steps that don't cost any money at all, right? And that's good design. So this is an aerial view of the site before we started. There was an existing middle school that was built in the 1950s, and Discovery was sited just to the south of that. But as we started, we looked at a lot of different ways in which we could site the building on this 25-acre campus that we were sharing with the middle school. And then we ran energy models right away as soon as we had basic mapping. So we were using modeling to kind of dictate how we did very basic moves. And so the worst performing model, which is the one on the top left, becomes your baseline. And then from there, we use a very simple metric in comparing moves where we say, what is the additional amount of PV you would have to buy if you did this move? And so you're seeing PV savings for all the different ways in which we change the orientation, change the blocking, change the stacking, change where we put the glass. And we really kind of take all that data and aggregate it. And we didn't really pick any one of these as a particular one, but we kind of borrowed from one scheme in terms of orientation, and we borrowed from another in terms of massing. There was a scheme that had the most amount of PV savings, meaning it would require the least amount of solar panels to get to net zero. But we rejected it because it didn't meet our other goals for a healthy building, particularly for natural daylight, right? You could have a building like this that would be really energy efficient, but would be a terrible place to be in, right? So we don't ever want to give up natural light and health and wellness. And in fact, we want these spaces to be heavily used and places where people want to be all the time. Something we hear a lot is that it's easy to get to zero energy in a K-12 school because it's only used 9 months of the year and it's not used all day. Well, I'm here to tell you that, at least in Arlington, that's baloney. These schools are operated 7 p.m. to 7 a.m. to 7 p.m. 6 days a week, with heavy after-hours use for after-school and heavy parks and rec use as well. So, and in fact, we want our best performing buildings to be the ones that are used the most, right? Because they're using the least amount of resources. So one of the things that we do is that we make sure that we are using glass where we want it, and as much as we want to achieve the goals. In this case, we had a southeast orientation. This was an area where we had some views over the treetops of Arlington, and we wanted to take advantage of that, but we would have paid a huge energy penalty. So what do? We put a giant roof extension over it, which created this great covered outdoor space that the school uses all the time when it rains, and essentially took the glass that was in a really bad orientation and essentially made it north-facing glass. So, and then elsewhere in the envelope, we are more judicious in our use of glass. So again, you can't make these decisions if you aren't energy modeling. You don't want to just say, take the approach, I'm going to do 30% glazing spread evenly across the building. You want to use your glass in appropriate places and then use less in others. Can't do that if you're not modeling. All things that are just basic designs that don't cost a thing construction-wise. So this is where we ended up in terms of how the building sits. It's a south-facing slope, and the building piers down to the south, which is a key component in designing for production. So here's that section. North is to the right, south is to the left. So none of these roofs are shading the other, right? If I took that drawing and flipped it 180 degrees, the tall roof would be shading the middle roof would be shading the lower roof. So designing with production in mind and making sure that you're going to be able to get the number of PVs on your roof is a basic idea that we start with. So here's a drawing that shows the roof with all of the 1,700 solar panels that are on it. Well, I want to show you the impact of a small mechanical unit or penthouse. This is a clean roof. There's nothing on this roof except for solar panels or skylights or solar tubes. No equipment whatsoever. Nothing to go on the roof and maintain. This is what happens if you say, well, we really need a packaged unit on the roof. So that's a, 30 by 20 or less size little mechanical room, and you can see the amount of shadow that it throws and just takes all of those out. So keeping the roof clean is a big piece of this. So those are a very quick overview of steps we take in design to make sure that we're designing both for energy consumption and energy production in the way we lay out the building. Moving on to systems, which are, of course, things that we buy with construction dollars that cost money. These are some of the things that Discovery uses. So we have a geothermal system with a distributed heat pump system. So there's no boilers to maintain, there's no chillers to maintain. Everything is a residential size heat pump, and there's 58 of them spread across the building, which allows us to do on-demand heating and cooling only when the spaces need it. So we have demand heating and cooling. This also allows us, because we're not trying to heat and cool a huge amount of air and pump it all across the building when only a certain part of the building needs it, we can right-size the equipment. And getting that down to the right level is really key. And also having a good envelope is how you do that. Domain controlled ventilation, there's a DOAS system that has heat recovery. It has MERV 13 filters on it. Each of the individual geothermal heat pumps for the classrooms have a MERV 11 filter, and all the classrooms have at least 2 operable windows. So this building meets all of the CDC criteria for reopening in COVID. And the building, and we monitor all the power, and the building has all LED lighting. I'll come back to that idea in a moment, but this was at the time, this was kind of revolutionary, right? This was 2013, and convincing the school system to kind of take a risk and go all LED was a big deal, right? This is commonplace now. So a lot of the things that we did are things that are just part of the practice now, and why I again say that zero energy is here to stay. One idea, a simple idea, is simplicity, right? The more complicated you're going to make your control system, the more likely they're going to fail, and when they fail, they always fail 100% on, right? You need to have conditioned air, you need to have light. So if you're trying to use complicated lighting control systems or complicated control systems to do this, that's not the approach that we take. In fact, we want to run everything through one building automation system and simplify down to one set of controls wherever we can. That also goes to the idea of where we put the air filters. Architects are terrible about just wanting to shove units above ceilings and in places that are hard to get to. Well, if you want clean air, make it easy to get to the air filter, right? Duh, that's kind of a common idea. So at Discovery, there's not a single, except for the VAV boxes, which are just controlling that fresh air from the DOAS system, there's nothing that requires any operation or maintenance above a ceiling anywhere. Everything is in a heat pump closet that's mounted on the floor, which I'm convinced is a key part of the building operating the way it does. Here's some other things that you'll get a chuckle out of that we had to do at the time to try to get to zero energy. We had to convince them that, you really should think about going to all laptops or iPads and stop buying these desktop computers for your classroom because of the extra energy that a desktop uses. You really should not run coax anymore, and you really shouldn't have to run as many Cat 6 drops because the new wireless standard is going to be faster. And think about going one-to-one. All of those things were like mind-blowing ideas 8 years ago, and now they're commonplace, and they were pieces that we used to get to zero energy. Same in the kitchen. There's no combustion at all in any of these buildings that we're doing. So we are truly 100% clean energy. There's a side benefit to that, right? Because you're not using open flames to fry food. And so we use steamers and combi ovens to heat food. So we're baking and steaming food, so the food is healthier. And then at the same time, we're eliminating the big type 1 hoods that are required when you have grease-laden vapors. So we're not pumping all this air out of the building and running all these fans. At the same time, the hot water heater is on a preheat system and is tied into the geothermal loop as well. The envelope is kind of the last piece here, and the piece that really kind of makes it all sing. You know, I'm the architect, not the engineer, so I'm a little more biased to the things that we do, right? But when we do this, we are absolutely relentless about air sealing in our detailing and in our work on the site. We look at trying to reduce the number of mullions wherever we can and increase the glass size. And I've already talked a little bit about sizing windows for views and quality, and not trying to do it for daylight harvesting with complicated systems, but use a single occupancy sensor, one sensor in the room that's controlling when we get fresh air, when we need conditioned air, and when lights go on and off. Simple system. What we're finding is that, and these are rough numbers, but what I've discovered looking at our numbers is, and I think I can say this with a good bit of accuracy, is that our buildings, we probably spend $200,000 to $250,000 more than the typical school in our envelope. Because we do that, and because we're taking the distributed mechanical system and simplified controls that are based on occupancy, if you truly right-size the mechanical system and don't over-design it, we're seeing about $500,000 to $600,000 less in mechanical costs. So a net of $250,000 less simply by designing the building the right way, with the right data. You know, this is kind of obvious, right? You know, the energy cost, the average energy cost in Arlington is almost $120,000 for one of their schools, right? If ICE costs $120,000, you darn right buy a Yeti, right? It's a little more expensive, but you get one, and that ice would take a lot longer before it melted. So our Yeti, in this case, was insulated concrete forms. This was very common in other parts of the country, but had never been done here. So we actually brought a Texas contractor to Virginia to do this, to pour these. So this was kind of something that was new for us. And then here is the details on the wall itself, the wall assembly itself, but also all the information on the envelope. I've got 3 different case studies here I'm going to show you, and I'm not going to read any of that data. But you can see the air leakage number that we have from the testing of 0.11 is one of the best we've ever had. And then I'm listing all the information on the U values for the glazing, the assembly, and all the insulation pieces. So that's an insulated concrete form. As we looked at our projects after this, we had 2 projects. A second project in Arlington that's now open and almost has 12 months of data. And then another school that's in a totally different part of Virginia, Harrisonburg, Virginia, where we used a system that was a combination of rock wool on the inside and spray foam on the outside, which has also given us good performance. I'll come back and talk about that one a little bit more in a moment. And then our newest one, which is a renovation addition, we wanted to try to get away from spray foam and from foams in general. And so this is all rock wool. And you can see the data that we're using there. So this is, I asked a CM after we drew these up to kind of price all 3 of them last fall. And you can see there's, they all fall between $50 and $60 a square foot. So all of them are kind of in the same range, price-wise. We also have been trying to look at embodied carbon. Now, embodied carbon is very difficult to figure out. And frankly, I'm not at a point where I really make a lot of big design decisions based on it, but it doesn't mean you stop trying. So we are looking at all of our projects in terms of tons of carbon dioxide per square foot that's embedded in the materials. And it was a little surprising here when we ran this. The one in the middle that says 0.0122, that's our most recent spray foam project. And we just used a spray foam that had a different blowing agent. And we don't like spray foam for a lot of other reasons, about it cracking and having long-term durability issues. But it turned out to be the best one carbon-wise. So we're continuing to look at this and trace it and figure out how we can do, how well we can do. The one on the far right is the one that's all rock wool. And it's pretty close in terms of coming in second on embodied carbon. I put this slide in here to really kind of make the point on what is required for code and what a high performance building is. So I'm gonna go from the bottom up. So the way this slide is arranged is the first column on the left is Reed Elementary, which is a school that we have under construction right now. So it's our most recent design. Immediately to the right of that in blue is the code that it had to use. Moving over to the right in green, you can see, so we were a 2013 code. You can see 2016 and 2019 ASHRAE 20.1, and also 2015 and 2018 of International Green Construction Code. So our U value on our roof is 0.03, and that's an R30, which we've been doing for a long time, and that's not average, that's minimum. And then you can look at the numbers on the glass, and they are kind of right in line with where code already is. And then air leakage, we're better. Code is dropping from 0.4 to 0.25. We're happy anytime we're under 0.2, and we shoot for that 0.15. And then the only thing that we're really doing that's over and above is there at the top of the chart on our wall installation, right? So we're going a good bit over what code is requiring. Even the current most stringent code, where they're requiring 12.5 continuous on the outside and 13 on the inside, we're doing a good bit better. But if I back up a slide, and if I took an inch out of the insulation on each side of that, which is really the difference, I guarantee you that the contractor is not going to price it much different if they notice it at all. So these are such low-hanging fruit in terms of getting to an envelope and getting to this building. This is a Bluestone Elementary that's in Harrisonburg, Virginia. I said I would come back to this later. Again, I also saw in the chat about socially diverse and economic areas. This is a designated refugee resettlement area. And I think there's students from 98 or 97 different countries that are represented in this school system. And this is in the Shenandoah Valley of Virginia. They have yet to purchase their PVs, but this building is operating at an EUI of 18 and was built for $257 a square foot. It's a couple years old. Some pictures from the inside. On the left here on all these slides are all the kind of basics of the approaches that we took. So I'm not going to read any of that, but we're sharing all this information as a case study. The one thing I do want to say about Bluestone is that we do a lot of POEs. You got to track your data, not just energy data, but how people will use the building. And what we found was that this, compared to the other elementary schools in the system, 36% fewer teacher absentees, which is just a phenomenal thing. That's how we can really make a big contribution to healthy buildings. This building was also the Center for the Built Environment in Berkeley awarded the Living Building Award last year. So we like to call it the happiest building in America, at least for this year. Right? This is our second project for Arlington that opened last year. So we are coming up on 12 months of data. It is a 6-story building. There's 4 stories above ground, and then there's a 2-level parking garage below. So that's 115,000 square feet, plus another 100,000 of parking that has mechanical ventilation, not heating or cooling, but ventilation and lighting. And so this is going to, when we have the data, going to be one of the biggest zero energy projects out there. And I can't wait to get to the data. Again, information on that project, how that works. This is one that is just finishing construction right now. This is a rec center also in Arlington. This used even a different type of wall system, a thermomass system where it had insulation in the middle and concrete on either side. I can't wait till I get a case study slide on that with all our data. And this is the one that's under construction right now, which is a renovation and addition. So the 2-story portion is really a renovation of that existing LEED Gold building. It's attached to a historic building, and then we are putting our high-performance building next to it. And overall, including the renovations, this building is also on track to reach zero energy. And stats on it and some pictures from the inside. What all this has led us to is that the system, as Reilly said, has changed its criteria. So this is the language they put in RFPs now for all their projects. You've got to hit these criteria. And again, this is not hard to hit. So it's changed the way they're procuring buildings, which is a great thing. I'll close with this one story that I tell a lot from Discovery, which is the idea of cost shifting. Cost shifting is a simple idea of going, just like the way we started the project. We were modeling and saying, okay, what's the PV offset that choice, right? If we do this, how many extra or fewer panels do I have to buy to offset that choice? And you can look at that on everything from policy to operation hours to set points to materials. And so we were at a point where we're really trying to push it and make sure we're going to achieve this goal on our first attempt at this. And we said, should we look at triple pane windows? So we plugged it into the Revit model, and we were able to do takeoffs on it and give it to the estimator. And they said, yeah, that's going to cost you $119,000 extra to go from double to triple pane. We then took that same Revit model and gave it to our engineers and said, run the energy model. And they said, yep, you're going to save some money, but if you buy $9,000 worth of solar panels, you'll offset the extra amount that that you would save. And so there's an easy decision, right? But you can't make that decision if you're not modeling, and you can't make that decision if you don't have PV in your toolkit, right? If PV was going to be an extra, you can't make that decision. So for me, the goal is for solar panels to be considered the same as steel and concrete when it comes to the materials that we use to design our buildings. So the takeaways that I'll give you from this in quick summaries are, at the very least, every building that you do can be zero energy ready. Solar panels are not free, but you can be zero energy ready and be on Reilly's list of emerging at the budget that is already there. I'm absolutely convinced of that, right? Number two, the people that tell you that you can't do it, that it's unaffordable, that it's unfeasible, are the ones that have never done it. So as my mama said, don't hang out with negative people. Find new people to work with. If your engineers aren't tracking the data on their projects and know how their designs perform, find new engineers. For your engineers out there, if your architects aren't asking you about EUIs and talking about air barriers and air sealing, challenge them. Find new architects. Find the people that are going to do this, because they're out there and it can be done. And then last, there's lots of different ways to get there. I hope the different examples of the case studies in the wall section show you that. And it's all using things that are in the market. These are not demonstration projects anymore. You don't need a grant. You can use the things that are out there and the approaches that are out there, and you can get to zero. Thanks.
Thank you. Thank you so much. We are happy to hang out with you and hear these stories today and in many days in the future. So we're hoping to have you back. And Reilly is going to share some of her awesome resources, just point you in the right direction if you are interested in making the case for zero energy projects at your school.
Thanks, Phoebe. I promise I'll do this really quick. I have a bunch, oops, wrong way, sorry. All of them are different. I just wanted to draw attention to some of the kind of key things here. Zero energy, is a process. NREL and the U.S. Department of Energy put out this guide that follows the process of zero energy. This is a really useful tool for stakeholders, and it's a little bit more user-friendly. But kind of the key resource here is this Advanced Energy Design Guide for Zero Energy Schools. I put this one in the chat too, because this is a prescriptive approach for you to follow step-by-step how you can implement zero energy in your school. The state of Virginia, I mentioned earlier, they adopted zero net energy for new construction in schools. They actually say that you have to follow this guide. So very important. Center for Green Schools has the Learning Lab, which is awesome. And Phoebe, I think it's still free during COVID, right? Awesome.
There are many lessons that are free. Yep, so check it out.
Great curriculum resources. Another kind of key thing here is NBI has put together this Getting to Zero Resources Hub, and within the hub are these zero energy schools section. And in there, we have a ton of different examples of state and local leadership, school district leadership, research and tools. There's case studies in there, the watch list I mentioned, and then there's these tools. I put one of these in here, the one on the right, the stakeholder engagement, into the chat. But this is a good document for you to reference. It has key messages, and then it can compare key messages to stakeholders based on their priorities, some funding messages for the board, funding messages for, or student outcome messages for features, anything like that. We also, part of the zero energy process is integrated design. So we have this integrated design charrette toolkit, which has emails and agendas. I mean, everything you need to get your integrated design charrette off of the bang. We also have the Zero Net Energy Project Guide. That's not school focused, but it is a helpful prescriptive path to follow also. Let's see what else we got here. Zeroenergy.org from DOE is also great. They've got more case studies and resources as needed. And then this is the last one. This is just a list of additional resources. I do also want to just mention, I had that list of resources for COVID in the beginning of the slides. There's also even more, and I should have put this on here, but I forgot, but NBI has a new COVID resources section where you can go and reference different building types. And, we mentioned the CDC guidelines, there's ASHRAE guidelines, all sorts of stuff. So I can follow up with that too.
Yeah, that'd be great, Reilly. We can include that when we send out the slides for folks, because you guys have been doing so much around COVID and Zero Net Energy. Awesome. Can you go to the next slide, actually, Reilly? We'll just put your contact information up. Thank you for folks. I know that we're over the hour. I'm impressed that we fit this much in an hour and 7 minutes. So for those who are able to stick with us, we'll take a couple questions. Chris, and thank you to folks from VMDO and everyone for answering questions in the chat. I think we covered quite a bit, but Kristen, are there any?
You guys were amazing at answering all these questions in here. I did find a few that I think might not have gotten answered. The first is, do you have any suggestions in addressing occupant transfer when, with the goal of net zero in mind?
Or zero, I think this was related to the zero carbon LEAP,
right.
Zero carbon certification. So how do we deal with transportation and occupant transportation? Have you guys dealt with that at all or have recommendations?
I've had this question. Carbon is tricky. I mentioned carbon accounting is tricky because there's different aspects of it. There's also embodied carbon, which is the actual carbon in the construction materials. So what I was mostly talking about today is operational carbon of the building, which is how you can offset with the renewables. If you're truly trying to go net zero carbon at your building and calculate that, I suggest you could break them up, just like you said, by transportation, by building. If you want to go embodied carbon with the materials, you can do that too. But I think it's really important to treat them all separately and treat them as just a big, long equation. I'm not as familiar with transportation or work in the transportation sector, but I do know, there's people who are dealing with carbon emissions with no idling, walking, school buses. I do know people that do work in the transportation sector, so I'd be happy to point you to them. I hope that answers that question.
Yeah, and for those projects, they're using ARC to document their transportation carbon impacts, and that's documented through a survey with any of the occupants. So, buildings that are in urban areas that are more closely tied to public transportation or schools that have a higher percentage of walkers or bikers, obviously are going to be ahead of the game there. So just encouraging those programs and offsetting where you need to.
Yeah, that'd be helpful.
Thanks, Kristen.
Yeah. Wyck, there's a question specifically for you here. Do you have net zero energy projects that burn fossil fuels for heating and do not have a geothermal mechanical system?
Okay, we do not have any zero energy projects that burn fossil fuels for heating. We don't have any zero energy projects that use fossil fuels for anything. We try to get the gas out, as Reilly said, and not have that and go all electric. So we are not doing that anywhere. The second question, that do not have a geothermal system. So far, no. All of our projects are geothermal with a distributed water source heat pump system.
Yeah, that's helpful. Thank you. And then I have one here. How is reporting data for net zero certification affected due to the school closures of COVID in recent months?
I answered that one briefly, and honestly, the simple answer is we don't know yet because the data isn't necessarily in on these buildings. NBI is actively working to evaluate that, and we'll be putting out either a white paper or a statement. I'm not really sure, but it comes into conversation almost every day. I wish I had a really absolute answer, just like I wish I could solve COVID, but I do not at this point. However, once we do have an informed decision, I mean, of course, the energy efficiency is going to look phenomenal on these buildings because no one is in them. But it could also bring to light, you know, inefficiencies in buildings. So there's going to be different aspects of it. You know, some buildings may still show that they have really high EUI even though there's nobody in them. So we'll make sure that Phoebe and Center for Green Schools is tapped in when we kind of come to a hypothesis on that.
Great, yeah. I think that the majority of questions that didn't get answered.
Yep, I think that was the last one.
Okay. Patrick just sent a follow-up question. Hold on. Wyck, if you have a client that is reluctant to go all electric because they will pay more for energy and can't afford PV, what would you do?
Well, I mean, I guess they're saying that natural gas, I imagine, is behind this question, being very affordable and used for heating. I think that there are certainly very efficient modern boilers and heating approaches that you can use that for. Of course, you're going to be using electricity for air conditioning, and the cooling load is still the dominant load in most parts of the country. I don't know where the questioner is located. We're in climate zone 4, so we get all the heat and humidity, and we get all the cold as well. And so that's still going to be a big part of it. And then I would also say that an option that we're doing more and more of our projects is to use a power purchase agreement, where Discovery actually went out and bought the solar panels. It spent $1.3 million buying solar panels, and it owns the panels, so it gets all the savings. Another way is to sign a contract, and you kind of move away from whoever you're buying electricity from now, and you sign a power purchase agreement with someone who comes in and puts PV on your roof, and you sign a 25-year contract and buy energy from them. Arlington is doing that now in their projects, and the cost is less than what the local utility provider is providing. So I think there's always different ways to do that. And you can have fossil fuels in the mix and get to a low EUI, absolutely. We're trying to get them out just so we can be 100% clean energy. But again, there's a lot of ways to do this, and I wouldn't discount gas as a component at all.
Great answer. And yeah, thanks for highlighting the power purchase agreement opportunity. Every state's different, but we are seeing more and more schools using that option across the country. More states that didn't offer that as an option, seeking policy to incentivize that. All right, guys. Well, thank you so much. This was an awesome presentation, and as I said, we look forward to hanging out with you guys again and bringing new stories and updates related to COVID and progress on these projects to you all in the probably early next year. Thank you, Wyck. Thank you, Reilly. Take care, everyone, and be well and be healthy and safe.
Thanks, Phoebe. Bye, everyone.
Thanks, everybody.